Here are graphs of two functions, and we want to investigate some features of these graphs. I'll start with the first graph on the left. Suppose this is x1, which means that the value of y at this point will be f x1, and suppose this is x2, which means the value of y at this point will be f x2, and just need to label this. This is, by the way, y, and this is x, and this is the original function. Now we can notice here that as x increases, okay, y is also increasing. As x is increasing, y is also increasing. So that's one of the observations, and I'm just going to write it below here. But before I do that, we can also notice some other observation. We can notice that the value of f x2 is greater than the value of f x1, and this is because of the fact that the value of y is increasing as x is increasing. Okay, so we can write that statement below here and say that the value of y is increasing as x is increasing. Okay, so that's one of the observations. There's some other observations. Okay, now if you look at this graph again, we can notice that we are moving uphill, all right, from left to right, which means that the slope will be greater than 0. All right, so we can add that statement here again and say that since we are moving uphill, and this is from left to right, the slope will be greater than 0. Greater than 0, which makes sense. And by the way, it's because of the fact that we are moving uphill. So how can we generalize this? We can say that a function is increasing when the gradient or the slope is greater than 0, which makes sense, right? So a function is increasing when the slope or the first derivative or the gradient is greater than 0. So we can write that using a mathematical notation here and say that hence a function is increasing when the gradient or the slope is greater than 0. That's very, very important, and we shall be using that fact later on to analyzing other functions. So that's the first case. Let's look at the second case. Okay, now the second case here, we have a function that is going or moving downhill from left to right, and just labeling this again, this is y, this is x. Now suppose this is x1. Suppose x1 is somewhere here. So this is x1, which means that will be f x1. And suppose this is x2, which means this will be f x2. Now we can see here that as x is increasing, y is decreasing. Okay, as x is increasing, y is decreasing. And therefore, we can go ahead and say that, and by the way, another observation you can notice here is that just following that statement that I've just said, fx2 is less than fx1, because as the value of y is decreasing, as the value of x is increasing, the value of y is decreasing. So we can write that statement as this: fx2 is less than fx1. And you can see the relationship between these two statements. This one here, okay, and this one here, okay. And it's because one function is increasing, another function is decreasing. And by the way, this is because of the fact that the value of y is, so I can just write here, the value of y is decreasing. As x is increasing. Okay. Another observation that we can make from this graph is that since you are moving downhill from left to right, the slope is basically less than 0. You're going downhill. So we can write that as an observation here again, that since we are moving downhill, from left to right, the slope will be less than 0. Which means that the function is decreasing. Okay? And what can we say if the function is increasing? The slope will be less than 0. Okay? So how do we write that mathematically? Or how can you summarize that using a mathematical statement? We can say that a function is decreasing when the slope is less than 0. So hence, we can say that a function is decreasing when the slope is less than 0. Okay? And this is very, very important, and we shall be using these observations later on to analyze different situations. Okay, let's look at some examples here. Find the intervals where this function is increasing. And I'll just use a highlighter to kind of give you an idea of what to do here. So let's first of all observe where the function is increasing. And I'll just use a highlight to show this. So this portion here, the function is increasing, and this portion here, the function is increasing. How about where the function is decreasing? We are going downhill, which means that will be this portion here. So we can go ahead and answer this question. Remember, we need to write those inequalities. So A, the function is increasing when x is less than -1 and when x is greater than 2. This is from the graph. And then B, the function is decreasing when x is between -1 and 2. Okay? And we can apply the same methods here. Okay? Again, using a highlighter, where is the function increasing? Increasing, that will be this portion. So increasing will be this portion of the graph. Okay? And this function here is increasing all the way. Okay? And here we are increasing this portion of the graph, and here we are increasing that portion of the graph. Okay, just need to make it that more accurate. So somewhere here. Okay, and then decreasing, that will be this portion of the graph, and then this portion of the graph. So we need to write these statements using inequalities. So A, um, okay, so A increasing, that will be when x is greater than 0, and decreasing when x is less than 0. Okay, as you can see from the graph over there. For B, increasing for all values of x, C, increasing when x is greater than 0 and when x less than 2. So increasing when x is less than 0 and when x is greater than 2. Decreasing when x is between 0 and 2.